Hello friends, in this video we will be discussing about sum of arithmetic progression. In other words, I can say that sum of n terms of arithmetic progression. Now let's suppose I have a progression here 5, 10, 15, 20, 25 and so on up to, let's suppose it goes up to 20 terms. Now how I can find sum of these 20 terms which can be represented by as 20. In our previous videos we discussed what is an arithmetic progression, and we also discussed about nth term of arithmetic progression. In this video we will be focusing on sum of n terms of an arithmetic progression. So there is a formula here which is very simple and straightforward. Sum of n terms of an AP is equal to n divided by 2 times 2a plus n minus 1 times d. So small letter d here is common difference, which we have already discussed. N is the number of terms. For example, if we want to find sum of 20 terms, then n would be equal to 20. So an a here would be basically the first term of the sequence, and n is again the number of terms present in the sequence or up to which we want to find sum. For example, if we want to find sum up to 15 terms in this sequence, then n would be equal to 15. If we want to find sum equal to 20 terms in the sequence, then n would be equal to 20. Now let's solve this example as 20, because I want to find sum of 20 terms of this AP, and it will be equal to 20 over 2, and value of n is 20 in this case. First term is 5 and common difference is equal to 5, 2 times value of a is 5 here, plus 20 minus 1 times d. Value of d here is again 5, which is common difference. 20 divided by 2 is 10, and this is 10 plus 19 times 5. So I get here 10 plus 19 times 5 is 95. So I get here 10 times 105, which is equal to 1050. So the sum of 20 terms of this arithmetic progression is equal to 1050. Now a question can come up in your mind that how this formula actually came into existence. Then this formula can be derived easily. For example, sum of n terms of an AP basically is sum of the first term, sum of second term, sum of third term, sum of fourth term, sum of fifth term, sixth term, and so on up to n terms basically. And we know that the first term is represented by a. Second term can be found by just adding small letter d to the sequence. Second term can be found by just adding common difference to the first term, and this third term can be found by adding common difference twice to the first term, and fourth term can be found by adding common difference 3 times to the first term, and so on. And this an would be basically equal to n minus 1 times d. Basically this is adding common difference n minus 1 times to the first term. So I get here a plus d, a plus 2d, plus a plus 3d, plus and so on, and a plus n minus 1 times d. Similarly, let's mark this as equation number 1. Similarly, I can mark Sn. I can write the whole thing in the reverse order here, which would be a plus n minus 1 times d plus a plus n minus 2d plus dash dash dash, and I will have a reverse order finishing like this, which is a plus d plus a. So if I add this, Sn with this Sn, I get equation something like that, 2Sn. Let's mark this as equation number 2. If I add this thing Sn with this Sn, basically I'm adding first equation with the second equation, I get 2Sn equal to something here on the right hand side. I would not go through the proof here. It's clearly written in the same post here which I'm posting above, and when you solve that equation you come up with n over 2, 2a plus n minus 1 times d, which is the formula for sum of n terms of an arithmetic progression. Similarly, I can modify this formula by writing something like this. So I just split this 2a into a plus a, and this n minus 1 times d is written as it is. And from our previous discussions we know that nth term of an AP is equal to a plus n minus 1 times d, which is this part here. So I can replace this whole part by an, so it's a plus an. So in other words, sum of n terms of an arithmetic progression can also be found if I know value of n. For example, if I want to find sum of 20 terms of an AP, I would know the value of n if I know the value of first term, and if I know the value of the 20th term, then I can easily find the sum of 20 terms of an AP. So this was it about sum of arithmetic progressions, and in the next video we will be doing lots of practice questions which will be related to our sum of arithmetic progressions, nth term of arithmetic progressions, and finding the value of common difference, first term, and so on. See you guys in the next video.